Good morning, everybody. It's a pleasure to be here. So what I want to talk about today, you can hear me well, everybody? Yes, no, it's fine. See, in the vision system it would not happen. Can we check why is this the... Just one dramatic pause, just 1 second.
It's the next slide. I press it manually.
But there is a
pointer.
I need the flow. Oh, here it is. Okay, we are back. So what do I want to talk about? So today, very briefly about us, just to give the context. Then I want to share with you, based on what we've seen in the market, what are some of the main challenges when going into deploying visual and quality inspection in real production network, real production line, which is quite different than being on the lab, than showing things working in the booth. We'll talk about the technology that we developed in order to compensate, among other, to compensate about those challenges, and we will dive in and see exactly how they resolve those challenges. So without further ado, just a few words about Inspekto, basically a German-Israeli company. We started developing our Vision AI, I think, almost a decade ago. Israel is well known about, high-tech, technology, development, etc. I'm very proud to say that we are doing also research, not just development, but applied research in the domain of Vision AI, which help us develop a very unique Vision AI technology that I will share with you in a minute. This is our product, the Inspekto S70, and the deployment that we have done with this product on real production line is the source of information that I'm going to share with you today. I think that today we have shipped over several hundreds of systems. We gained a lot of experience in different use cases in terms of quality inspection, of plastic molding, metal forging, PCBA assembly, electronics, automotive, sanitary, buildings, print, etc. And a lot of the stuff that we've seen is what we incorporate in this session in order to share with you those challenges. So a lot of practical experience about real-life deployments. So the main challenges when it's going to the real-life deployment in the real production line. A production line is a very dynamic environment, constantly changing. And roughly, we can divide it into 4 categories of change, of constant change. The first one is the environment. Easy examples are lighting, day, night, cloudy day, sunny days, vibrations are on or off from an adjustment system, etc. The environment of the production line changes, and the inspection solution needs to be able to mitigate it. Second one is the production process. The production process, again, continuous change. Tooling needs to be changed. A new production system, a new injection molding system needs to be installed. Derived impact on the produced part. How do we mitigate those changes that keep happening in the line? Another, going even deeper, another domain is the part itself. The part can, during the life cycle of the inspected part, it could be 3 years, it could be 5 years, it could be longer. The part to be inspected are continuously changing. For example, a subcomponent, a supplier of today in the supply chain challenges that we have today, a subcomponent can be changed and then suddenly the part looks different, nothing similar or very different than the samples that I used before, and the inspection system suddenly stop working. Or an FCO, a field change order for design notification, etc. And lastly, the defects themselves. In many cases, we've seen that after 6 months of operation, a new type of defect appears. A defect that we did not plan for, we did not know about, it was not in the defect catalog. A side note, us in Inspekto, we do not need those defect catalog. We do not need to know about those defects up front. But in general, new defects can appear. The requirement for the inspection detection can change. A customer of a customer suddenly puts in a claim and saying, hey, this is not good for me. So a level of defect, permittable defect that was previously okay, suddenly becomes not okay. How do you change it? How do you mitigate those changes? So in general, very hectic and ever-changing environment. And the concept of machine vision, ability to say that this, look at the produced part, an ability to make the smart decision, is it okay or not okay, is becoming a real challenge when you take all those changes into consideration. And the derived question, the dramatic pause, the question that we put on ourselves is how do we ensure that through the life cycle? It's not just making the inspection, meeting the the site acceptance test, the SAT, the required performance. This is a challenge by itself. But the real challenge is how do we ensure the performance throughout the life cycle of the inspected part? I want to talk to you briefly about the technology, and then we'll see how the technology is applied to solve those challenges. So we developed what we call the AMV technology, AMV AI technology. Basically, when we started to look at the machine vision market, what we see today is that conventional machine vision is very complex. In most cases, it's a project that is created to solve a specific need. New project, a new integration of elements of cameras, lenses, software, optics, lighting, etc., etc. And in general, we see that the conventional machine vision, most of the machine vision systems today have two main attributes. Attribute number one, there are use case specific. For every need, basically needs to integrate a different solution. Attribute number two, there are extremely intensive resources from the end user point of view in terms of deploying them and maintaining them, providing upfront the defect catalog, providing hundreds of samples of okay parts, hundreds of samples of not okay parts, hundreds of samples of not okay part of each defect type. So implementing them and maintaining the performance is extremely cumbersome. Come Inspekto, and we understood this environment, and we set on a path to change it. We developed a technology that we call the autonomous machine vision AI, which is fundamentally different than the other vision AI out there in the market in several aspects. First of all, this is a pure end-to-end AI solution, 3 AI engines working in tandem, really mimicking the way the human vision works. The first engine, the way our brains control our eyes in order to adjust to whatever it is we are looking for, whatever is in the environment, controlling the iris, etc. Our first engine controls the electro-optic system and adjusts it to the specific use case. And it controls it in real time. So any environmental change that are happening in terms of lighting, etc., are automatically adjusted and mitigated. The second engine that we have, the recognition engine, is all about recognizing that this is the part that I'm looking for. As a human, before deciding if this is a defect, yes or no, I need to make sure that this is the part that I'm looking for. So this is the recognition AI. And the third one, which is an extremely powerful AI engine here, is the inspection AI, which is all about deciding yes or no, defected or not defected, good or not, okay or not okay. This is running on our proprietary electro-optic system, which is extremely flexible and versatile, and together provides the solution that we are offering or enabling this autonomous machine vision technology. So basically, what our position, what the technology enables us to do in the market is to move from this domain of use case specific, of intensive implementation resources, to move it towards a new domain of simple use case agnostic, the same product, not project anymore, product, applicable to many different use cases, can be reused. Some of our customers are starting with one project, and then they have an urgent need, they take it to another project, and then they of course install another one for the original project. A product, not a project, versatile, use case agnostic, and the implementation is extremely easy, and therefore by the end of the end user themselves, delivering complete independence to the manufacturers and not reliance on experts, on the availability of suppliers, etc., to come and mitigate and optimize the inspection system. So this is the core offering of Inspekto. I will not go to all the details of comparing solution with this technology versus conventional solution, but the main difference I want to show you is this is an end user centric machine vision. The idea here is the end user with zero understanding about machine vision, zero understanding about programming, zero understanding about deep learning, etc. He is using and deploying it himself, extremely easy and immediate. And this is the core fundamental change, a paradigm change with this technology. Now let's go back to our challenges. So remember, we are talking about 4 domains of deployment challenges: about the environment, about the process, about the part, and about the defects themselves. And how do we mitigate them with this technology? So first of all, let's talk about production environment change. Lightings, day, night, a cloudy day, vibration around, etc. And this relates very strongly to our first engine, the acquisition engine, the one that can in real time adjust the electro-optics to the specific use case. What you see here are images of different parts from different industries, different use cases, different scenarios, different distances with our optical zoom in the same solution, in the same Inspekto S70, generated to all those different use cases. So it's not just optimizing for the specific use case per case, it is doing that in real time. So this technology enables us to mitigate if there is a day, night, cloudy day, if there are vibration, we can ensure that we acquire the image only when the vibrations are settling down. So this real-time adjustment of the electro-optic system based on this AI engine, this acquisition AI engine, is what enables us to mitigate all those environmental changes that are happening on the production line. Very interesting element of this acquisition engine is a unique technology that we developed to eliminate reflections. Reflections are the source of all evil with machine vision, right? They are hurting our image. So we developed the technology that enables us to eliminate reflection. Here you see on those images the before and after cases. With reflection, when the image is extremely saturated and you cannot see anything out there, and without reflection, when the image is sharp and the detection and analysis can happen. By the way, we are demonstrating, among others, we are demonstrating this technology in our booth here in this hall at 504, and everybody, of course, are very welcome to join and see it. So this is our acquisition engine, and this is what enables us in real time to mitigate any environmental change that are happening on the production line. Let's talk about next, the process and the part. Changes in the process, changes in the part, both of them are realized by the part look different than what I was expecting or what I was planning for in the setup, in the original setup of the solution. So here the main contributor to our ability to mitigate those changes are the second and third engine, the recognition AI and the inspection AI. Those two together enable us to mitigate those changes. Here you see our recognition engine, the ability to recognize what I'm seeing based on a single image, no multiple samples. Extremely powerful recognition engine, very similar performance to the human understanding that what I'm seeing is what I'm looking for. This engine enables us to see what I'm looking for, and also provide an exact, ultra-accurate location of the part within the field of view, which help us, again, if needed, to eliminate reflection, to stitch the images together. By the way, you see this identification, recognition, whenever you see the polygon around it, it means that it's recognized, done in live video. And, wait a minute. And this is the inspection engine. The inspection engine, I think, is the most powerful AI, vision AI technology out there in the market. Basically, what we developed here is the ability. I'll take one step back. Everybody says that vision AI or AI in general is like human thinking process, right? You heard that before. Standard vision AI or AI is basically like a human baby sees something for the first time without prior experience. While I'm, as an adult, when I would receive the task of inspecting this part, even though that I never saw it before, I know what a scratch is. I know what a defect is. So only a few minutes to look at it and a simple explanation, I will be able to extract my experience in order to now do the job of inspecting it correctly. This is the technology we developed with this inspection AI. So basically, this is a pre-trained model that we trained on thousands of parts, on millions of images. He knows what is a defect. He knows what are problems. And then when we apply it to the specific use case, we only need to adapt it, to show it very few OK samples in order to adapt it to the specific use case. And he uses the general experience, I would call it, to make sure that the resources I need to, the process to adapt it is immediate and extremely easy. This is a big part of what eliminates the need to any programming, calibration, deep learning, expertise, etc. And in general, all I need is to show it OK samples, 20 to 30 OK samples, and the adaptation is done. Yes, I can fine-tune the performance with adding selective, not OK samples if I think that I need to increase sensitivity here and there, and we'll touch base on that in a minute. All of them, those two engines together, and this is for the first time in the industry that this capability is now available, those two engines together continuously monitor the inspection happening, the production line is producing. Each image is inspected and analyzed. In addition to making the decision, OK, not OK, defected, not defected, also this technology enables us to analyze every image, every part that is inspected, and detect and decide if it is worthwhile to consider it as an element to optimize the performance. So every image is evaluated. Does it have a potential to improve the inspection? Did I see here something different than what I used to see until now? If yes, they are collected into what we call a recommendation group. What could be a reason to put in a recommendation group? For example, the system sees that the part is in a location that it did not see before. Or it could be that I started to see the part, yes, it's an OK part, but I'm starting to see within the analysis that I'm doing that it's different than other OK parts. There are changes in the part that are making different, and I see the variety started to grow. Still an OK part. But this technology enables us to understand that, wow, something has happened. It's very important to use this sample as a reference for future inspections. It could be a new type of a defect that is seen, detected, but until now was not seen before, and I want to make sure that I continue the sensitivity to those new type of defects. And this recommendation then can be added to the inspection model in order to optimize it, and vice versa. So what you have here in this concept, you have a continuous improvement, continuous optimization method that basically whatever happening in the process, whatever happening on the product, help the end user to mitigate it immediately and smoothly. Again, zero understanding about machine vision, calibrating, adjusting, etc. Just understanding what it sees and adding it autonomously into the recommendation group and then into the performance. In general, sorry about that. In general, this is how you look for. You see the samples, you see the group, the different groups of this recognition engine divided and created, and those samples then will be added. And as I said, the technology enables us to edit within a minute or two. It's not going back and shutting down and waiting to call to somebody, waiting for the expert to arrive, turn off the inspection, recalibrate it, and go through several iterations of training until I'm happy with the performance. By a click of a button, 2 minutes, and then the performance is updated, zero to be done by the end user himself, not dependent on any expert to waiting for him to arrive to my production line. So this is the autonomous continuous optimization, a major capability that enables us to mitigate those changes within the production line and the produced part. Lastly, I want to talk about the defect. As we said, the defect can appear a new type of defect, or in many, many cases that we heard from our customers, the inspection requirement changes. I need to be more sensitive. What was used to be a permitted defect suddenly is no more, or vice versa. So I need to be able to modify the required threshold, what is a defect and what is not a defect, in a very unique manner. And this technology is again, the last engine in our architecture is what is contributing to our ability to adapt here. And what we developed with this selective self-supervised, this is not supervised, this is not supervised, this is a self-supervised technology. And if we want to deep dive into it, you are again welcome to our booth and we can talk about it in length. This technology enables us to do the following. Let's say that this is our inspection solution now. In my part, there are three types of defects. There are scratches, there are deformation, there are missing material, etc. And I'm currently happy with my performance. Something happened. My customer called and says, you know, I'm not happy anymore. You send me up. You send me parts that I'm not happy with the quality you're sending me, or my customer is not happy anymore. I guess you guys are under major suspension, right? You're trying to understand. I'm getting there, just one sec. Remember the optimization, the recommendation engine. Up. Suddenly there is a change in the requirement. Can become from my customer can come from my quality assurance department, can originate from anywhere. What do I do then? What in general I will do, I will take this sample of, and this what technology enables us, I will take a sample of this defect and I will add it as a sample to the inspection, and I will see what happens. In general, standard vision AI, when I'm trying to make the system more sensitive to one type of a defect, I'm affecting the performance to other type of defect. So if I have those three levels of performance, I would call it, or detection thresholds for type of defect, that I'm trying to increase the sensitivity to one of them, de facto what I'm causing is a decrease on sensitivity to the other. And I was happy with this performance. I don't want this short blanket effect that I'm pulling to one side, I'm degrading the performance on the other side. What our technology enables us with this specific engine is selectively, and this is the self-supervised effect that of this AI technology, is to selectively increase the sensitivity to this specific defect type. So yes, scratches, for example, I want to now to detect even a finer scratches, but not to degrade the detection performance of the other type. Or if a new defect appears, completely new defect appears, and I want to make sure that I'm very sensitive to it, but I'm not degrading the sensitivity to other types. Only this is enabled with this kind of ability to control the sensitivity to each defect by itself and not affecting each other. And to do it with, again, enable the end user to do it himself with zero machine vision, AI, configuration, etc. But a few click of a button, requiring only what we call the domain expertise, understanding what it is you're inspecting, nothing to do with machine vision. So this is our story. This is what we try to solve, or what we are solving with our technology. A lot, as I said, hundreds of systems out there, a lot of practical information or experience about real production, and we'll be very happy to share and show it more to you with our booth on 504 there in the corner of this hall. And I'm open for any questions now or later. Feel free. Thank you very much for your attention.